Welcome to the final of 5 videos exploring the VCU-based design example for Avnet's UltraZed-EV Starter Kit. This design example enables hardware-accelerated processing of H.264 and H.265 video available in the EV family of Zynq UltraScale Plus MPSoC devices. In the 4th video, we reviewed how to interface with a USB webcam and preview that video stream locally on a DisplayPort monitor. In this video, we're going to demonstrate that local preview, but also the encoding and streaming of USB webcam video source. We're going to highlight the architecture of the GStreamer pipeline for previewing and accelerated encode and network streaming of webcam video. We're also going to review the session description protocol configuration for this pipeline, which is necessary for subscribing to the network stream on the remote end. And then we're going to finish that up with a complete end-to-end demo. So let's start by taking a look here at the desktop. I'll make this full screen. So here we've got a 4K Samsung monitor plugged into the UltraZed Starter Kit through DisplayPort. We've got a Ethernet cable going to a gigabit Ethernet connection. We've got a micro USB headed to a USB port on the PC so that we have serial access to the Linux console. Got a Wiz Systems USB 3 to 2A adapter that is plugged into a Targus USB 3.0 hub. And then this cable hanging off of here runs to a webcam on the desk that is pointed up at a 55-inch Samsung television on the wall that we're going to use as a video source for the webcam to play back. I'm going to go ahead and boot this platform, and we're going to talk a little bit while this is booting about the documentation in the repository. So in the repository, under the RDF folder, documentation testing, we've got 3 sets of documentation here for DisplayPort, the RTP streaming, and USB webcam. Now you can go in here and get straight to the test documents, or I recommend actually going back out if you're browsing the repository to the project releases. And this is going to highlight the release notes documentation version. So we'll scroll down here in the release notes to the testing getting started instructions and click on the link instructions used to validate the operation of the design. This provides just a little bit better layout so you can see how the test documentation flows logically from starting with the DisplayPort display to working with the decoder, then working with the USB webcam, and then finally in this video, we're going to actually test the encode and stream of that USB webcam. So I've got these documents, these 2 documents open in another tab here. Let's take a first look at the test documentation. So I'll highlight that this test documentation is designed to build these examples from the ground up. So if you don't have any experience in GStreamer or doing any of this media processing under Linux, it's a great way to learn and get your feet wet because we step through the pipeline step by step and building each component of the pipeline so you can understand how all the pieces fit together. So at the very top here is just a highlight of all the elements used in this demo pipeline. So we start off with our webcam, and we're going to bring it in through the V4L2 source element, and that's going to provide us access to the USB webcam's data. Then we're going to send it into a T element, and what T does is it basically creates a parallel data path for the input data to go. So it's like creating a copy so you can process it in 2 different data paths. So in the first data path, actually in both data paths, we're going to queue the data, so provide an individual buffered copy of the data to each data path. And then the first data path here is for the actual encode process. So we need to send it through the video convert element, which is going to do data format conversions so that the format of the data going into the encoder is a native format the encoder knows how to interpret. Then once it goes through the encode process, we're going to get compressed video out, and we're going to queue that data to buffer it. Then we're going to put it through an RTP element to attach RTP transport headers. And then we're going to send it out over UDP sync, which is going to push it out on the network stack and send it over to a remote unit for reception. And if we step back here in the pipeline and look at the parallel data path, we've got our second copy of data going through a queue, and then that's going to be sent directly in its native format out to the DisplayPort using the KMS sync element, which is the way to get data out of a GStreamer pipeline into the kernel mode subsystem's display driver. The other thing to highlight in this demo is that on the remote end, we're going to be using VLC Media Player, and we're going to be inputting an SDP file into VLC, and that's going to tell VLC what to listen for, what format stream is coming in, so it knows how to interpret and listen to the data stream that's going to be coming over the network and play that back on the remote PC. Now I'll highlight, I'm going to scroll down here in documentation, down near line 1124, Actually, I'm sorry, yes, 1124. So at the end of this test document, there's actually, after we've built the pipeline and gotten the pipeline working, we're going to go create the session description protocol file. So I highlight in this documentation the session description protocol format, and then we step through how to pull out of the GStreamer pipeline all the configuration parameters you need to create this file. So if we take a look in the repository in this test folder at the other file, it's actually an example copy of an SDP file for this demo pipeline. So if you were going to use this out of the box for your demo, what you're going to want to do is change these IP addresses in here. It's in here twice. And this is going to tell VLC to listen for this host IP address is going to send us a network stream coming from 192.168.1.131. And then there are additional parameters. You can read the documentation to see what all of this means. But you have to set parameters and the properties of the video stream coming over for VLC to know how to interpret that. So we're going to use this example file inside of, on our host PC inside of VLC. I'm sorry, inside of the VLC media player in order to receive the stream over the network. All right, so the first thing we're going to do in order to get started, I'm going to switch back over here to TerraTerm, and we're going to take a look at the hardware and accelerated elements that are in the GStreamer pipeline. So Xilinx provides 4 elements for us to use in GStreamer to access the VCU. There's an H.265 encode and decode and an H.264 encode and decode. So we're going to do a H.264 encode in this example. So what we want to do is we want to use the GST inspect tool to take a look at the parameters of the encoder. There's a lot of stuff that just kind of scrolled through the display, so let's scroll back up here and see what we're working with. So each GStreamer element has a source and a sync pad. Not all of them, some of them are sync only or source only, but the encoder has an input and an output. So the sync pad is the input to the encoder. That's always going to be raw video. You'll see here, and it's going to have a width, height, frame rate, whether it's interlaced or field order mode. And then the source pad is going to be the output of the encoder back into the GStreamer pipeline, and that is always going to be an H.264 compressed stream. So the source and sync pads are pretty simple. One of the things that's more complex about the encoder is all of the element properties. So a video encoder has many different knobs you can twist, so to speak, control quantization, the quality, how the stream is sampled and compressed, what kind of bit rates, if you use filler data, latency mode, how many buffers you use for prefetch. So there are a lot of parameters here, and this is a good time to highlight if you'd like to learn more about those parameters. Xilinx has an excellent set of documentation in the product guide. So let me switch over here. I've got the product guide open. So PG252, the Logic Core IP product guide for the video codec unit. We're going to go to page 122. Table 12.4, GStreamer encoding parameters. So this is a great place to go and read up on what all these encoding parameters control and what configuration values are valid. And this documentation is updated basically with every new release of the VCU IP block and drivers. So you can go in here and understand, what the recommended values are, what the defaults are, and what this actually controls. So I'm going to switch back over here to the test documentation. All right, now I think we're ready to actually go and do a demonstration. So I'm going to load, first we're going to load a demo pipeline. I'm going to copy and paste this, and I'm going to go ahead and kick this pipeline off. I'll jump back out here to my desktop, and you'll see the webcam is playing back on the local display here. And you might wonder why it looks kind of crummy. So that is because we need to adjust the exposure of the webcam I'm using to record this video. So whenever you're pointing a webcam at a display that's out emitting light directly into the camera, you might need to adjust some of the lighting settings. So I'm going to go and turn down the exposure on my webcam a few notches, and you'll see that that picture comes into focus a little better and the colors are no longer washed out. So we're going to use that setting here for our demo. I'm going to go ahead and start this network stream actually. And I'm playing this back on on an NVIDIA Shield. So now that we've got the webcam that I'm recording this desktop demo on, we're actually going to go and I'm going to background this. we're going to adjust some of the parameters of the webcam that's recording this and sending the data through the UltraZed. So if you want to learn more about how to do this, I suggest you go back and watch the 4th video where we dive into this in a little bit more depth. But I'm going to turn off auto white balance. I'm going to set the color temperature to 6K. I'm going to turn down the exposure, and I'm going to set an absolute exposure so it brings in less light, and turn off autofocus. So now we'll go back here to the webcam, and you'll see the preview that's coming out. As the light changes in the scene, it's going to be less reactive to that with this change in parameters. All right, so let's cancel this pipeline. Now we've got this tuned in. Let's take a look at a streaming demo at 720p, 10 frames a second coming from the webcam. So the first thing I want to do, I'm going to open up a Windows Explorer window here and show you in the documentation test folder is this example SDP file we discussed earlier. This has the IP address that VLC should be listening for data to come from. So I'm going to double click this and just open it in VLC. So we see VLC media player here. It's sitting here listening for something coming up over the network. Now I'm going to switch back over here to TerraTerm, and what we're going to do is we're going to copy and paste in a GStreamer pipeline for accessing 720p video. So we're going to do 720p, 10 frames a second from the camera. It's going to go through the encoder. We're going to payload it with RTP, send it out UDP sync. Now this is where if you're adapting these pipelines for your own demonstration, you're going to want to set the IP address on the remote end here that's going to receive the network stream. So this is sending it to my PC on 1.103. And then the other part of the pipeline is going to send it out KMS sync to display on the local monitor. So I'm going to go ahead and kick that off. We've got our pipeline running, and I'm going to switch back out here, and we'll see that the webcam here in VLC, we've got reception over the network. I'm actually going to start the video now. We're going to watch the Big Buck Bunny trailer. You'll see it's playing on VLC over the network, and then we also see it here on the desktop display, DisplayPort monitor connected to the UltraZed board. So you can see these kind of side by side. And if you notice, the video is a little choppy. Let's see if we can do a full screen. We minimize the webcam here locally, and let's put this full screen so we can take a quick look here at the video itself. So you'll notice that it's pretty crisp. You know, it's pretty good resolution, but the motion is a little choppy. That's because the webcam is only sampling this at 10 frames a second. So in a little bit, we're going to switch back to a lower resolution, but watch it at 30 frames a second. You'll see the video is not as crisp, but the motion is captured really well. So I just wanted to highlight that. All right, now let's take a look at what this means in terms of processor load while this is playing back. So we're going to take this pipeline and put it in the background, and then we're going to use top, take a look at what kind of resources this is taking. And I'll show you as this is refreshing. We're still doing streaming over the network and playback locally. So I'm going to highlight here in TerraTerm this top entry, GST launch. That's the GStreamer pipeline's involvement, and it's about 62 to 64% of a single Cortex-A core is being utilized to handle all the processing. So that includes buffering the data, sending it through the video convert element, which is a software piece. In an actual end application, you would probably want to implement that in hardware using a mixer or something in the PL to do your data format conversion before going in the encoder, so software doesn't have to actually touch that piece. Then that's also coming back out of the encoder, going through RTP, and then packetization over UTP and sending out over the network. So 64% total for that whole data processing. And then we've got this K-worker thread that's about 12 to 13%. And what that is servicing the USB interface, bringing data in from the webcam. And then part of that GST launch is also sending that back out to the DisplayPort. So I just wanted to highlight, that's what the CPU utilization looks like for 720p, 10 frames a second. So let's cancel this. I'm going to step back out. And we're actually going to cancel this pipeline. What I'm going to do, and you see that the stream paused over here in VLC. So it's no longer receiving, but it's still listening. So what I'm going to do next is we're going to do the same pipeline, but we're going to switch over to VGA resolution, so 640 by 480, and we're going to configure the webcam for 30 frames a second. So you'll see here we're going to do 30 frames a second, 640 by 480, and I want to do this to highlight. So now we've got a smaller video. Now we've got a smaller video here, but there's no motion blur. You see all 30 frames a second. So the source video is 30 frames a second coming from the desktop. The actual TV is playing it at 60 frames a second, but it's being sampled at 30, and there's almost no discernible blur or motion blur. So it looks actually pretty good. Now if we go and make this full screen, bear with me a second, go and make this full screen, you'll see it's not quite as crisp as it was at 720p, but it's actually not bad. But the motion looks much better than at 720p 10 frames a second because it was noticeable lag. So that looks pretty good even at VGA resolution. So I'm going to take this out of full screen mode. Now you can see them side by side again. You've got a reduced resolution at VGA, but it's better frame rate and plays really well over the network. So let's take a look and see what that means in terms of processor utilization. So I'm going to put this back in the background, and we're going to take a look using top at what the CPU is doing. So if you remember at 720p, it was about 63% of a processor of one Cortex-A core to do that video processing, the whole pipeline. When you step down to VGA, it's about 43%. And again, this isn't a super efficient pipeline because we're doing a software-based video format conversion before we ship it off to the encoder. So you can significantly reduce the processor involvement if you do that in hardware. And then, of course, for servicing USB video with this K-Worker thread, it's about 13% as well. And this is just kind of chugging along. So the video looks nice, nice and smooth, not as quite a high resolution. And with that, I'm going to close out the pipeline. And that concludes this demo and concludes the video series. Hopefully this series provides a great introduction for you and helps you get started using the VCU acceleration capabilities of the UltraZed-EV Starter Kit. Thanks for watching. And